Hi again. In this video we are going to look at composing functions together. That means that we are going to first talk about evaluating functions, the composition of two functions. We are going to use composition of functions to create a brand new function, and we're also going to talk a little bit about the domain and range of the functions that we're composing together. Okay, so when I say function composition or composing functions, it's really just a fancy way of saying that we are going to embed one function into another function. So really it's a form of substitution, a fancy form of substitution. So let's say that you have these two functions. We have f of x and we have g of x. If I were to ask you to evaluate f of g of 1, I am not asking you to multiply 1 times g and then that times f. These parentheses are not multiplication parentheses, they're brackets. Another way that you're going to see composition is like this, f composed with g. These two things mean the same thing, although in number 1 we're evaluating it at the number 1. So what this means, the embedding that's happening, is that we're going to start on the very inside of the middle bracket. So we're starting with this 1 here. We're going to take that 1 and substitute it or embed it into the thing that's right outside of it, the g. So I'm going to find first what g of 1 is. So let's take that 1 and let's put it into g of x. 2 times 1 plus 3. 2 times 1 is 2, and then when I add 3 to it, I get 5. So that means this thing, g of 1, is 5. So I'm going to write f of 5. And now I'm going to do another substitution or embedding. I'm going to evaluate f at the value 5. So I'm going to plug the 5 in there. 5 plus 7. 5 plus 7 is 12. And so that's my fully simplified composition. I start on the inside and I work my way out. I take the number I'm the value that I'm evaluating, I plug it into the function on the inside of the embedment, and then I take that number, that was 5 in our case, and I plug it in and evaluate at the outside function. Let's do one more of these. Let's this time do the reverse of what we just did. Let's do g of f of 1. So I'm going to start on the inside with my 1, but this time I'm going to substitute it into f. So I'm finding f of 1 first. F of 1 is using this f of x function, so that's 1 plus 7, which is equal to 8. Now I'm going to take that 8 and plug it in to my g function because f of 1 is equal to 8. So I'm going to plug it in there. And then I'm going to take that 8 and evaluate. So 2 times 8 plus 3. 2 times 8 is 16. 16 plus 3 is 19. So that's my evaluated composition. Okay, so now let's look at finding a new function. If we wanted to find the new function f composed with g, that means we're going to take all of g of x, notice there's not a number on this inside embedding, we're going to take all of g of x and we're going to stick it in wherever there are x's in the function f. So I'm going to take all of g of x, this 2x plus 3, and I'm going to plug it in to f of x where the x is. So instead of writing an x there, I'm going to write 2x plus 3, and then I'm going to put that plus 7 on the end. So this quantity is my new x instead of this x, and then I've got 7. Then I need to combine like terms. So I've got 2x and then 3 plus 7 is 10. So that's 2x plus 10. That is a new function because it's not one of these two originals that we just had. Let's do another one of those. Let's do it the other way this time. Let's do g composed with f. So we're going to take f of x and we're going to plug that equation or that expression in, x plus 7, wherever g has an x in it. So I'm going to take all of this guy and put it right there. So I'm going to do 2 times, and then I'm going to embed my x plus 7, which is what f is equal to, and then I've got that plus 3 on the end from the g of x. So again, this equation is a new equation where I've taken f of x, this guy, and put it in where that x was. So now I need to simplify. So let's distribute this 2. That gives us 2x plus 14 plus 3. And then when I combine like terms, that gives me 2x plus 17. And that's my new function there. Okay, so now we're going to use that new function to evaluate f of g of 1. Remember, we just found f of g of x, so let's put this 1 into our new function where the x is. Let's do 2 times 1 plus 10. 2 times 1 is 2. When I do 2 plus 10, I get 12. Do you notice anything there? Finding f of g of 1 here versus up in number 1 where we found f of g of 1? Do you see that you get the same thing? That will always be the case. When you evaluate the value by plugging it into one and then embedding that in the other, you'll get the same thing as if you compose the two functions together, like we did here, and then plug that value 1 into that new function. Let's look at one more. Let's find g composed with f, evaluating it at 1, using this new function. So that's 2 times our x value, which is 1, plus 17. 2 times 1 is 2. 2 plus 17 is 19. Again, we got the same thing that we got up here when we evaluated g of f of 1. Okay, so one important thing that I need to mention here before we go any further with composition and the different representations is that you need to be sure that you're thinking about the domain of a composition function. Whether it's f of g of x or f composed with g, because remember these two things mean the same thing, you have to look at any restrictions on what the input is as well as what the result is, the ultimate output. So let's look at an example of that. If we're looking at these two functions, these two maps, f and g, we have two different equations here, or maps here. Remember that the left circle are the x values, the inputs, and the y values, or the outputs, are on the right. So both of these individually have input and output values. But when we compose them together, so we take an x value and we put it into g, that means we're starting with these x values, and then we take these and put them into f. These are our output values when we do this full composition. So the domain, the thing that we started with, are these guys, the set of numbers including -2, -1, 1, and 2. But the range, the output of f of g of x, is these guys over here after we put x in and then we composed it with f. So that is -2, -1, 1, and 2. You notice anything funny about that? What if we write them as ordered pairs, so the x's and y's together? -2, -2, -1, -1, 1, 1, and 2, 2. What do you notice? Do you see how the x and y values are the same in each of the ordered pairs? The domain and range match up. This is a special kind of composition that we're going to be talking about in the future called an inverse. Let's look at one more of those before we move on to the next topic here. So let's think about the domain of g of f of x. So we need to find our x's that are being put into f. The f x values or input values are these over here. So my domain is 0, 1, 3, and 4. The range is the output values of g of f of x. So if I take my x values and I put them into f, that maps over to here. And then when I put those, compose them into g, that means I put them into g, and it maps out over here. These are my final result in that composition. So the range is 0, 1, 3, 4. The ordered pairs are again 0, 0, 1, 1, 3, 3, and 4, 4. So again, this is a very special type of composition. It's not always going to work out this way, and that's why domain and range are going to be something that we look at often in the future. Okay, so let's talk about a real-world application, because your head might be spinning a little bit with why on earth are we sticking functions into other functions and that kind of thing. The crazy thing is that if you are one of those shoppers who tries to calculate how much something costs before you get up to the cash register, if it's on sale, you are doing the composition of functions without even really realizing it. Whenever you buy a sale item and you try to figure out if you want to pay however much it actually costs, or calculate do you have enough money to buy it now that it's on sale, you're doing composition. So let's look at an example. If you want to buy a $50 shirt, but it's on sale, it's 20% off. You can calculate, along with the 5% sales tax, how much that shirt's going to cost and if you can really afford to buy it. So first, let's just figure out the price of the shirt after the sale, because it's not going to be $50 if it's on sale for 20% off. We do that by taking the total cost of the shirt, $50, and we take 20% off of it. So we subtract whatever 20% of 50 is. Now we do need to figure out what 20% of 50 is. If we multiply 0.20 by 50, that will tell us what 20% is. 20% of 50 is. So let's see, 0.2 times 50 is 10. So this is 50 minus $10. You're saving $10 by that 20% off sale, which means then that this shirt after the sale is really going to cost you $40. Now there is sales tax, so it's not actually going to be $40. It's going to be a little bit more than that. 5% of 40 needs to be tacked on. So if we need to find the price of our $40 shirt with sales tax, that means that we need to take our $40 shirt that we're buying and add the sales tax to it. To find the sales tax, if it's 5%, that's 0.05, and we need to multiply that by the 40 so we can see what quantity we need to add on to our $40 shirt. 0.05 times 40, well that's 2. So 40 plus 2 means that our shirt in total, after the sale and with sales tax, is going to be $42. So in this process that we just did, that maybe you do naturally when you're at the store trying to decide if you want to buy something or not, the first thing that we needed to determine was f of x, the price after the discount. And then after we knew the price after the discount, then we could figure out the price after sales tax. And that process gave us the final cost of the shirt, and we were composing information. We took our $50 shirt, the X is the 50 here, we figured out what the price being discounted was, and then we used that piece of information to figure out what the sales tax was. So we found one value and then plugged it in and used it to get to the value we really wanted to know, G of f of x, the price after the sales tax, or the total price of the shirt, the final cost of the shirt. Okay, so there are a couple of problems on the Now You Try to give yourself a little bit of practice with function composition. Now you should be able to, oh, where'd it go? There it is. Evaluate the composition of two functions, meaning you plug in an x value and then plug that number into the second function. You should be able to use function composition to create a new function where you take a whole function and plug it into another one. And you also should be able to look at domain and range of function composition. So give those Now You Tries a try.